Hello. This is a video about quadratic equations or the quadratic equation formula, but particularly about how you prove it. Anyway, my name is Paul, but that's enough about me. Let's get on to looking at this quadratic equation formula. When I was at school, I saw this. It was a long time ago. And you probably know it anyway, that if you have a quadratic equation and you have it in the form of the top line here, so you have it in the form of ax squared plus bx plus c, where a, b, or c can be any number, equals 0, then the formula for finding x is on the bottom. X equals, and it's minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you don't have a quadratic equation in this form, then you have to convert it into that form before you can use the formula. Notice that it's plus or minus. I'll talk about that again in a moment. But I used to see this quite often when I was at school, and I thought, well, why is that right? Why can we use that formula? Well, it turns out that it's simply a matter of algebra. It's very straightforward, and we'll go through the algebra to show you how it works. Now, notice plus or minus because this is a square root. And whenever you have a square root of any number, it can take a positive or negative form. So, for example, just by way of aside, if we take about the simplest possible quadratic equation, x squared equals 9. Well, you know that x equals 3 because 3 3s are 9, but also, of course, x can equal minus 3 because minus 3 times minus 3 is also 9. The square of a negative number is always positive. But it also follows that whenever you take a square root, you have to put in the plus or minus sign. I'll come back to that in a moment. Anyway, let's continue. Here we are. Here's the formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Well, what I'm going to do is go from the formula to the original rather than the other way around, because all the steps are reversible, so you can easily get back again from the beginning, from the end to the beginning. Okay, the first thing we're going to do is multiply both sides of this equation by 2a. Now, you know that if you multiply any equation both sides by the same number, it doesn't affect the truth of the equation. So we multiply the left side by 2a, we get 2ax. We multiply the right side, we just get rid of this divisor 2a, so we just get minus b plus or minus square root of b squared minus 4ab. Now the next thing I think what we should do is to add b to both sides, so you end up with 2ax plus b. This b then disappears from the right-hand side, and you just have plus or minus b squared minus 4ac. Well, fairly obviously, I think, the next thing we should do is square it. So let's have a quick look at that. So we've squared what we've got this now. We've got 2ax plus b equals plus or minus the square root of b squared minus 4ac. And now we're going to square both sides of the equation. You're perfectly entitled to do that. If you square both sides of the equation, the equality will still remain true. So we square this side, 2ax plus b, all squared. And now this simply becomes, because that's a square root, it simply becomes b squared minus 4ac. And notice now that because we've squared it, we don't need the plus or minus anymore. Minus 3 squared is plus 9, so it's plus 3 squared. It doesn't matter. So we can get rid of the plus or minus sign at this stage. Now we multiply out the bracket on the left-hand side, and it's straightforward how you do this. You know that if you multiply out a bracket like this, you start off with squaring that. We square each of the terms, so 4a squared x squared, plus 2axb plus 2axb. You do that twice. So you get 4axb or 4abx, because it doesn't matter what order you put them in, plus b squared. So that's multiplied out the brackets. We've done nothing to the right-hand side, so that's still b squared minus 4ac. Okay then. So that's where we were. That line is one we had just a moment ago. That's where we were, as you can see. And what we're going to do now is to subtract b squared from both sides of the equation, which means we just get rid of that b squared term, and we end up on the next line without the b squareds. Then we simply add 4ac to both sides. So on the left-hand side, we have 4a squared x squared plus 4abx plus 4ac. On the right-hand side now, we've added 4ac, so we've got 0. So that's where we are. Now you can see that when we multiply out this term, we end up with 4a times ax squared, 4a times bx, 4a times c, all equaling 0. and then we simply divide both sides by 4a, and we get our original form of the quadratic, ax squared plus bx plus c. So we've gone from the formula to the original form. And you can easily go back the other way. All of these steps are reversible. And the only one that you have to watch a little bit is this one. Because when you take the square root of this, going the other way, you have to remember the plus or minus. Whereas coming the way we went, the plus or minus, of course, disappeared. So we have actually shown that the formula, that, is exactly the same, actually, as that. There's no difference. That's how we proved it. Now let's go back to that original simple quadratic that we used right at the start. X squared equals 9. Now in order to make it work with the formula, we have to go into the form x squared minus 9 equals 0 by subtracting 9 from both sides. And now what we see is that ax squared, well, a is 1. And plus bx, well, we don't have a b is 0, so that will disappear from the equation. Minus 9, so c is minus 9, equals 0. So we slot this into the equation. Now we lose both of these b's. We know that a is 1. So 4ac is 4 times minus 9, which is minus 36. So minus 4ac is minus 36, or plus 36. And so if we slot all that into here, we get x equals plus or minus the square root of 36 all over 2. Well, you know the square root of 36 is 6. So it's plus or minus 6 over 2, or plus or minus 3. So we've just shown the formula working with a very, very simple quadratic. Well, as I say, it was something that puzzled me when I was a child, and I hope that you found it of some value, and thank you very much for listening.